Hello everyone, welcome to lecture series on Automata and Compiler Design. I am Gangappa from the Department of Computer Science and Engineering, AIML. Today I am going to talk about how to convert NFA to DFA. So this is one of the important concept in the examination point of view. So I request everyone to listen this lecture carefully. Let us go with one example. So these are the steps that are required to convert NFA to DFA. Basically, it is a quite simple problem to convert NFA into DFA. Generally, NFA contains more number of states than DFA. While converting NFA into DFA, DFA may take several states, equivalent states of NFA. So these are the steps we need to follow. So I will explain these steps by taking one example. So this is an example. If we go through this example, you can easily understand that this is an NFA. So because when we go through the diagram, that is Q0 on A, it goes to the Q0, and Q0 on A, it goes to Q1. So there are two states are possible on the same input and the current state. Therefore, this is the example for the NFA. So how to convert this NFA into DFA? Generally, DFA is a deterministic finite automata. It may be useful to find the deterministic path, so that we can avoid our confusion in which path we need to go to find the solution to the problem. Let us see how to convert this NFA into DFA. So step number 1, what we have to do here is, first we need to consider the start state of the NFA. So here starting state of the NFA is Q0. Q0 is the starting state of NFA, and inputs that are applicable on the start state is A and B. Let us see this. So let us apply this. So let us do the transactions. Q0 on A, this is Q0. Q0 on A, Q0 on A, it goes to Q0. Q0 on A, it goes to Q1. There are two next states possible on the same input. This is the transition for the state Q0 and the input A. So this is one we have got. Second one is Q0 on B. Because Q0 is the initial state, already we have seen how to convert, how to get the transition on the input A. Similarly, now we are going to see how to get the transition on input B from the state Q0. So this is how we get Q0 on B, we can go to the Q0. So what we do here is we need to enter these values into the table. So as shown in the table, let us see this. This is the table. So this is the DFA table actually. DFA table. In the DFA table, what we are trying to do is we are taking the current state as well as input symbols. So already we have seen A is one input symbol and B is one more input symbol. Q0 on A, it goes to Q0. Already we have got here. Q0 on B, it goes to Q0. Q0 on B, it goes to Q0. So after that, this is only the one step we need to do while converting NFA into DFA. After this step, we can observe the next state column. So these are all the next state columns. This is one next state column. 1 minute. This is one next state column. This is one more next state column. A column and B column. So on A column, there is one next state. On B column, there is one more next state. In this step, what we are going to do is we are going to compare the next state Q0 Q1 with the current state Q0. So if both are same, we need not consider the next state as the current state, and we do not make any transitions. Otherwise, we have to do the transition. For example, Q0 is the current state and Q0 Q1 is the next state. Q0 is the current state, Q0 Q1 is the next state. Both are different, both are not same. Both are not same means, so we have to perform the transition on the Q0 Q1 state. Q0 Q1 state can be the next new next state. So for this next state we have to apply the transition on input A and transition on input B, right? So this is one new state we have got here. And the next one is in the column B, we have one next state, that is Q0. Q0 is compared to the Q0 in the current state. Both are same, so this cannot be the new state. Only one new state, that is Q0 Q1. So this step is repeated until no more next states are generated in the column A and column B of the DFA table, right? Now we are going to perform the transition on the next state Q0 Q1 with input A and B. So let us see that. It is better to take the diagram. Q0 on A. So here is Q0 Q1 is the next state, right? New state. So we have to perform the transition Q0 Q1 on input A. Q0 on input A, already we know that Q0 Q1, Q0 Q1, Q0 on input A, Q0 Q1, Q1 on input A. Q1 on input A, what is there? Q1 on input A, it goes to Q2. It goes to Q2. Q0 on input A, it goes to Q2. Therefore, Q0 Q1 Q2. Q0 on input A, it goes to Q0 Q1. Q1 on input A, it goes to Q2. Therefore, next state generated by this transition is Q0 Q1 Q2. This is how we can get. Similarly, next transition is transition of Q0 Q1 on input B. On input B, what we get here is Q0 on B. Q0 on B is Q0 only from the diagram. Similarly, union Q1 on B. Q1 on B, we get only one next state, that is Q1. So finally we get Q0 Q1. Q0 Q1. So these are the next state generated from the current state Q1, Q0 Q1. Now we have to enter these values into the table as shown here. Q0 Q1. Q0 Q1 on A, it goes to Q0 Q1. Q0 Q1 on B, it goes to Q0 Q1, right? Next step is comparison. So here we have to compare the next state columns in the DFA table with the current state column. So in the next state column Q0 Q1, Q0 Q1, that should be compared with the current state column Q0. So this is different one, and Q0 Q1 with the current state is Q0 Q1, both are same. So this has been processed, so we need not worry. And come to the next one, Q0 is quite similar to Q0 in the current state, therefore this is not the new state. And come to the next one, Q0 Q1 Q2 is compared to the Q0. So this is somehow different one. This is somehow different one. Therefore here we got one different one, that is different new state. New state. In this step is Q0 Q1 Q2, because Q0 Q1 Q2 is not matching with, this is not matching with Q0, not matching with Q0 Q1. Therefore this is new state. Therefore this is new state. If we get any new state, then what should we do here is we should apply the inputs to make a transition. So in the next step we are going to perform the transition. So transition for that is Q0 Q1 Q2 on A, what is the next state? Q0, Q1, Q2 on B, what is the next state? Now we are going to do that. So Q0, Q1, Q2 on A can be written as Q0 on A, Q0, Q1, Q0 on A, Q0, Q1, Q1 on A, it is Q2, Q1, Q2 on A, it is Q3 from the diagram. This is from the diagram, NFA diagram. And by combining all of them, we get one state, that is Q0, Q1, Q2, Q3, right? So this is one state generated here. This is one state. Next one is Q0, Q1, Q2 on B. So this transition can be expanded as Q0 on B. What is the next state? Q1 on B. What is the next state? Q2 on B. What is the next state? So Q0 on B, Q0 is the next state from the diagram, NFA diagram. Q1 on B, Q1 is the next state on the NFA diagram. Q2 on B, Q3 is the next state on the NFA diagram. So it is better to keep NFA diagram in every slide so that you can easily understand the transition. How can we do this? After that, we should make all these entries in the table as shown here. So here we have enter the values for the current state Q0, Q1, Q2. This is the next state. This one is the next state. Q0, Q1, Q3. Q0, Q1, Q3 is different from the current states. And Q0, Q1, Q2, Q3 is also different from this one. Therefore, there are two new states are generated here. There are two new states. What are that new states? Means one is new states generated at this step. Q0, Q1, Q2, Q3 is one new state. Second one is Q0, Q1, Q3. There are two new states, this one and this one. Now, if there are any one new state appeared in the next state column of the DFA table, then we have to again perform the transition by using the input symbols A and B. Now here I am going to take the transition for the state Q0, Q1, Q3 with the input E. With input A, Q0, Q1, Q2, Q3 with input A, Q0, Q1, Q2, Q3 input B. So what we get here? So Q0, Q1, Q2, Q3 with input A can be expanded like this. Q0 on A, what is? Q0 on A, what is this? Q1 on A, what is this? Q2 on A, what is this? Q3 on A, what is this? So this can be expanded as shown here. After expanding like this, then we have to find out the next state. For the next state for Q0 on A is Q0, Q1. Transition of Q1 on A is Q2. Transition of Q2 on A is Q3. Transition of Q3 on A is no more transitions. There are no transitions. Therefore, pi is the answer for that. So by combining all these values, we get one state, that is Q0, Q1, Q2, Q3, right? So this has to be taken into the table for the new state Q0, Q1, Q2, Q3 with input E. Similarly, Q0, Q1, Q2, Q3 with input B. What should be the next state? So this can be computed like this. If we compute like this, we get the next state, that is Q0, Q1, Q2, Q3. This is the next state. If we expand like this and if we take the values from the NFA diagram, we get the next state for the state Q0, Q1, Q2, Q3 with input B, right? And after that, we have one more new state generated from the previous step, that is Q0, Q1, Q3. So again, here we need to make the transition for the state Q0, Q1, Q3 with input A and B. So that is shown here. So Q0, Q1, Q3 with input A can be expanded as transition of Q0, Q1 union transition of Q1 A union delta of Q3 A. So delta of Q1 A value is taken from the diagram as Q1, Q0, Q1 union transition of Q1 with A from the NFA diagram we get Q2. Transition of Q3 with A is pi. There is no transition, right? So by combining all of them we get one state, that is Q0, Q1, Q2. Similarly, we should make one more transition with the state Q0, Q1, Q3 with input B as shown here. Q0, Q1, Q3 with input B can be expanded as shown here. Q0 on B union delta of Q1 on B union delta of Q3 on B. So after expanding like this, then we should get the next state value for this transition. We should get the next state value for this transition. We should get the next state value for this transition. From the NFA diagram, we can get the next state values Q0, Q1, Q2, right? So by combining all of them, because there is an union operation, so we get one state Q0, Q1, Q2. Now we should mark all these values in the DFA table. In the DFA table as shown below. So for the state Q0, Q1, Q2, Q3 with input A, the next state is Q0, Q1, Q2, Q3. On input B, we have got the next state Q0, Q1, Q2, Q3. So this center has been made here. Similarly, next new state is Q0, Q1, Q3. For this transition with input A is obtained as Q0, Q1, Q2. Next one is Q0, Q1, Q2. Q0, Q1, Q2. Now these are the states generated here. Then what should we do here is we need to verify all these values with the current state values. Suppose if this one is matching with any one of the current state, then in that case this state cannot be the next state. Similarly, let us go with compare this with the current state values. Q0, Q1, Q2, Q3 is not similar to this. This is not. Now we compare this one. This is not similar to this. This is not similar to this. This is not similar to this. This is quite similar to this. Therefore, this is not Q0, Q1, Q2, Q3. So this is quite similar to this. Therefore, this cannot be the new state. Right? Now, let us go with one more. This one. Compare this Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3 is quite similar to Q0, Q1, Q2, Q3. Therefore, this cannot be the new state. Why? Because this has been processed here, right? Therefore, that cannot be the next new state. Now go to the next one, that is Q0, Q1, Q2. Let us consider this. Q0, Q1, Q2 is compared with Q0. This is not same. This state is not same as this. This state is quite similar to this. Therefore, this cannot be the new state. Now compare this with this. This is not new state. This is not new state. And this is quite similar to this. Therefore, this cannot be the new state. So there are no more new states are generated in this step. Therefore, there are no more new states are generated at this step. Therefore, we can stop the conversion step, and we should mark the initial states as well as final states in the DFA diagram. Let us see one by one. So there are no new states generated here. Therefore, the above table is the transition table corresponding to the new DFA. So this is the DFA table, right? Now, let us finalize the final states. So how can we mark the final states in the DFA table means? So to mark the final states and initial states. Let us go to the NFA diagram first. In the NFA diagram, let us go to the NFA diagram. This is NFA diagram. In the NFA diagram, Q naught is the initial state. Q naught is the initial state. Q naught is the initial state. And Q2 and Q3 are the two final states. Initial state and two final states. So initial state should be the same as the initial state in the DFA. Therefore, Q naught should be the initial state in the DFA as well as in the NFA. Therefore, Q naught should be the initial state. And how can we make the final states? To mark the final states in the DFA table, we should remember the states Q2 and Q3. Suppose any one of the state that consists of one of the states Q2 or Q3, then that state can be considered as the final state in the DFA. So remember, Q2 and Q3 should be included in the DFA states. Then that state is considered as the final state in the DFA. Therefore, here the final states of the DFA can be marked as Q0, Q1, Q2, because Q2 is the final state in the NFA. Therefore, Q0, Q1, Q2, this entire one is considered as one state, right? Now Q0, Q2, Q3 is included here. Therefore, this can be the final state. This entire can be the final state. This one can be the final state. And Q0, Q1, Q3. Here Q3 is there. Therefore, this entire can be the final state. Therefore, there are three final states. This one, and this one, right? So this is shown in the next slide. Like this, we can mark the final states in the DFA table. Sorry. So now we are going to use some notations to represent the DFA states. So Q0 is represented as capital A. Q0, Q1, the entire one is one state. So that can be represented as B, because Q0, Q1 is one state. So it is better to use another symbol, one capital letter, to represent entire state as one unit. And Q0, Q1, Q2, that is one unit, one state, that can be represented by C, and similarly D and E, remaining states. So using these symbols, we can draw the table. The table can be seen like this: current state, capital A, and input symbols A and B. Capital A on small a, it goes to B, and capital A on small b, it goes to capital A, and so on. This is how we can obtain the DFA table from the NFA. This is the procedure how to convert NFA into DFA, right? Shall we go with a small example, or shall we conclude? Let us go with a small example how to convert the NFA into DFA. Here I am drawing a small diagram, NFA diagram. So NFA diagram, NFA to DFA. Consider the NFA diagram. Q0 on A, it goes to Q0. Q0 on A, it goes to Q1. And Q1 on B, it goes to Q1 on B, it goes to Q1. And Q0 on B, it goes to Q1. Suppose this is one NFA. Now let us see how to convert NFA into DFA. First step is better to draw the transition diagram, NFA table, transition table. transition table for that. So Q0 is the initial state with input A with input B. Q0 on A, it goes to Q0 and Q1. Q0 on B, it goes to Q1, and Q1 on B, it goes to, this is pi. Q1 on A, there is no transition. Q1 on B, it goes to Q1. Now this is the NFA table. Now let us convert this NFA into equivalent DFA. To convert NFA into equivalent DFA, what should we do? In the first step is we should consider the first row of the NFA table. First step is we should take the first row of the NFA table as it is in the DFA. Here I am writing DFA table. So A, B, Q0 on A, it goes to Q0, Q1. Q0 on B, it goes to Q1. Q0 on B, it goes to Q1. First row is considered same in the NFA and DFA. So after that, we should compare the next state values with the current state value in the DFA table. So let us go with the first one. Q0, 1 minute. Q0 is the current state, and this is compared with the Q0, Q1, because this is the next state in the DFA table. This is not quite similar to this. Therefore, Q0, Q1 is the new state. Similarly, Q2 is compared, Q0 is again compared to the next one, Q1. Q1 is the next state. So again, this is not quite similar to this. Therefore, there are two new states generated in the DFA table. So let us go with the one by one. Here I am taking the Q1 as the next current state, and Q1 on A. From the diagram, Q1 on A, there is no transition. Q1 on A, there is no transition, so value is pi, right? So like this we can mark. And Q1 on B, transition is, here I am writing Q1 on B, it goes to Q1. Q1 on B, it goes to Q1. Now one more new state, that is Q0, Q1. So here new states, let us take the new states one by one. First new state that was generated is, first new state is Q1. Second new states Q0, Q1. So this has been processed. Now we have to process this, and similarly we should compare this with this. So both are quite similar, therefore this cannot be the new state. Therefore here I am ignoring this, and one more state is left in the next state column of the DFA table, that is Q0, Q1 state. Now here I am taking Q0, Q1 state as current state, and we should apply the inputs. Q0, Q1 on input A, what is the transition? Q0 on A, it goes to Q0, Q1. Q1 on A, it goes to no next state, therefore pi. So final answer is Q0, Q1. Q0 on A, Q0 on A, Q1. Q1 on A, there is no transition, pi. So what should we do here is we should write the entry here, Q0, Q1. as the next state, and similarly we should perform the one more transition, that is Q0 Q1 with input B. Q0 on B, it goes to Q1 union Q1 on B, it goes to Q1. So finally we get one next state, that is Q1. Now I'm going to have this. All of you note down this. So again, these states need to be verified. We need to compare the next state column values with the current state. So no more here, this cannot be the next new state, this cannot be the 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 new state. So all states in the next state column have been processed. Therefore, what should we do here is we should stop the transitions, conversion transition, right? So we can stop it here. And after stopping that, what should we do here is we should mark the initial state and as well as the final state. So already I told you that initial state in the NFA and DFA should be the same, that is Q0. So Q0 is marked as initial state in DFA. And how can we mark the final state? To mark the final state in the DFA, what should we do here is we should consider the final state in the NFA and we should verify whether that state is included in the DFA states or not. Suppose here Q1 is the final state in the NFA, Q1 is the final state. So whether this Q1 is included in the any DFA states or not. Q1, this cannot be Q1, this is the Q1, therefore this can be the final state. Here Q1 is included, therefore this can be the final state. There are two final states are marked in the DFA. Now after that, we should draw the DFA diagram from the DFA table. 1 minute. DFA diagram. Here I am taking new pen, new color. Better to take this. Take different colors so that you can easily understand that. So first thing is, what are the states here? First, it is better to write the states. Q0 is the one state. Next state is Q1 is one more state. This is one state, this is one more state, this is one more state. There are two states, three states. This is the final state. And next one is Q0 Q1 is the one more state in the DFA. These are the states. After taking the states like this, then we should make the transitions, I mean draw the edges. So Q0 on E, it goes to Q0 Q1, Q0 on E. So here I am taking one more color. So better to take this color. Okay. So Q0 on E, it goes to Q0 on E, it goes to Q0 Q1. And Q0 on B, it goes to Q1. So like this we can mark the edges. And Q1 on A, there is no transition. Q1 on B, there is a transition Q1, that is self loop. Q1 on B, there is a self loop. Q0 Q1 on A, it goes to Q0 Q1, this is a self loop. Q0 Q1 on B, it goes to that is Q1 as the next state. So when we observe this diagram, each state with the different input symbols contains only one transition. Therefore, this diagram is deterministic diagram. Deterministic. That is why this is called DFA diagram or deterministic finite automata. So this is how we can convert NFA into DFA. NFA into DFA. With this I can conclude my session. Thank you. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.